Apollo 11, this is Houston. How do you read? Apollo 11, this is Houston. Radio check, over. Roger, we're copying you about 5 by 2, very weak. Can you give us a status report, please? Loud and clear now, Mike, and we understand that you are Doc. That's affirmative.
Hello, Apollo 11, Houston. We recommend you accept the 949, continue through your sequence of sightings, and then we'll analyze the data afterwards, over.
Okay.
On board was a fourth brain, a small computer called DISCI, which solved problems and helped with a long sequence of systems checks and data exchange with Earth.
Houston, Apollo 11, Star 40 has just disappeared now in the sextant. Could the trunnion angle 47 something be a little high?
Stand by. Hello, Apollo 11, Houston. We'd like you to press on to Star 44, over.
Yeah, roger. How many marks?
They found their way across the sea of space, navigating by the same stars that guided Columbus to shores unknown.
11, Houston, we copy 2 good marks, over.
Okay. Okay, drug removal is coming next.
3 days falling to the moon, free of the gravity of Earth. No up or down, no day or night. A sense of stillness while traveling at the speed of a meteor.
About how long it'll be before you start closing the limb back up, over.
An invisible speck in the night, somewhere between here and there, constantly monitored from Earth. Within this tiny spacecraft, a temporary Earth environment, warmth, air, food, water, everything necessary to sustain life. Beyond these fragile walls, nothingness, absolute cold, an end to life. The most important function of the spacecraft, life, was also monitored constantly through telemetry, the heartbeat and breathing of each astronaut. Although each breath was 30,000 feet farther from Earth than the breath before it. Should one heart flutter, it would at once be a matter of concern to millions worlds away. Unlike any other place man had traveled before, space could provide him with nothing. It is a vacuum, devoid of every element needed for life. To send man into this nothingness, to protect him, it was first necessary to define him. What is the human machine? How does it function? What is the nature of its nervous system? Its respiration? Its circulation? Digestion? Sight? Hearing? Balance? Its endurance? What gases to breathe should he take with him from Earth? What atmospheric pressure suits him best? Is it possible to give him a more efficient atmosphere for space travel than nature provides on Earth? The moon is 250 degrees hot in sunlight and 240 degrees below zero in the middle of its night. How long can a man bake or freeze? What protection will he need from this inhuman environment? What strains will the heart take when the pressure of gravity is removed from the limbs? What protection will the body need from sudden deceleration or acceleration? Man's sense of direction, speed, and balance are easily fooled. Can his mind be trained to ignore false signals from his senses? We were defining the physical man in absolute terms. Once we knew man's limitations, we could build him an artificial environment for space travel. Columbia, the command module, was a supreme achievement of the technology of its age. It was a mini-planet, complete with its own environmental control system, telecommunications, electrical power, guidance, navigation, stabilization, propulsion, reaction control. It provided hot and cold water and removed carbon dioxide from the air. 3 men could live here for more than a week, eat, work, sleep, shave, exercise, and listen to music. It was micrometeor-proof, burn-proof, and seaworthy, and it could tilt itself in any direction. In short, it was the most intricate and sophisticated machine ever made by man. As for man, however, we're stuck with the original model. All we can do is add an outer layer of things he does not naturally have. Space medicine showed us where man is vulnerable, and we learned to compensate for most of the weaknesses with technology